Hi students, today we will be discussing the previous year questions of the chapter Chemical Bonding and Molecular Structure, and these are the questions which were asked in JEE Mains 2024. So I hope you have watched the videos related to atomic structure. Now we will be continuing with the next chapter, Chemical Bonding and Molecular Structure. So we will move to the first question. Here we are having an assertion and reason based question. So we will just read these statements. Assertion is that pH3 has lower boiling point than NH3. So can you just say whether it is right or wrong? Yes, it is right. pH3 is having lower boiling point than NH3. And the reason, what is the reason given? In liquid state, NH3 molecules are associated through van der Waals forces. So it is said that NH3 is having van der Waals forces, but pH3 molecules are associated through hydrogen bonding. In the light of the above statements, choose the most appropriate answer from the options given below. So you know that the first one is right. pH3 has lower boiling point than NH3. But the second statement is not right. What is the reason? You know that NH3 is not having van der Waals force. If you take the structure of NH3, you know that you will be having 3 hydrogens and you will be having a lone pair of electron. And you know that this hydrogen can form hydrogen bond, right? So here you will be having hydrogen bond. But here what it is given? It is given that NH3 is having van der Waals force, right? So it is a wrong statement. So among this, which is the right one? A is correct, but R is not correct. So the fourth option will be the right choice. So here the problem is that NH3 is having the hydrogen bond, but they have given that NH3 is having van der Waals force. Because of that reason, the second reason is wrong, right? So it was actually an easy question for you. Now we will move to the second question. Right. So here, what is the question? Arrange the bonds in order of increasing ionic character in the molecules. So we have been given certain molecules and we have to see which molecule is having the highest ionic character. So whenever we are searching for the ionic character, we have certain rules. So the first one is that if the smaller cation and the larger anion, you know that covalent character will be higher. So we need to find the ionic character. I'm saying that if it is a small cation and a large anion, the covalent character will be higher. Now, if it is a large cation and small anion, we can say that ionic character will be higher. So we have to see for which is the larger cation and smaller anion to find the larger ionic character. And the next thing is that if the electronegativity between atoms, between atoms are higher, we can say that ionic character will be higher, right? And another thing is that for alkali metals, the electronegativity will be less, while for halogens, the electronegativity will be higher. Right. So using these many information, which is that large cation, small anion, ionic character will be higher. If the electronegativity between atoms are higher, ionic character will be higher. And you know that alkali metals will be having very less electronegativity and halogens will be having very high electronegativity. With these principles, we can solve this problem very easily. So here we know that we are having LiF. Right, here it is an alkali metal and you are having a halogen. So obviously LiF will be having very high ionic character, and you can see that N2 will be having the least. So LiF will be having the maximum ionic character and N2 will be having the least ionic character. And followed by, you can see here, again an alkali metal is coming and you are having a chalcogen, oxygen. So after LiF, it will be K2O. Then after that, we will be having 2 halogens here. right? So after that we will be having ClF3, then we can find out the order very easily, and the third option will be the most appropriate. So here LiF will be having the maximum, which is followed by K2O, then ClF3, SO2 and N2. So this will be the order of ionic character, and we can solve this particular problem using this principle, keeping this principle in your mind. So I hope this problem is easy for you, like you have understood the principle behind solving this particular problem. Now we will move to the next question. So here we have to find out the number of molecules ions having trigonal bipyramidal shape. Trigonal bipyramidal shape. So if you know the hybridization of each molecule here, we can find out the shape of that particular molecule. So for that reason, we have to know the steric number. And here, if you take this PF5, you will be having this particular steric number as 5, and it will be sp3d, right? sp3d. And for sp3d, you will be having trigonal bipyramidal shape. Now coming to BRF5, you will be having 5 plus 1, 6 will be the steric number, and it will be sp3d2. In this case, you will not be having trigonal bipyramidal, it will be square pyramidal. So here it will be square pyramidal. So we will not be having trigonal bipyramidal. Coming to this particular PTCl4, here also we will be having a square planar structure, square planar. And here for BF3, it's a very familiar compound. 3 is the steric number. It will be trigonal planar. And coming to FeCO5, here also we will be having 5 as steric number, and it will be trigonal bipyramidal. So we will be having, PCl5, you know that PCl5, the steric number is 5. So for PCl5 also we will be having this particular trigonal bipyramidal shape, and it will be sp3d. So you will be having PF5, PCl5 and FeCO5 as the molecules which are having trigonal bipyramidal, and their hybridization will be what? sp3d, right? They will be having the hybridization sp3d. So how many number of molecules? We can say that 3 molecules will be having trigonal bipyramidal shape, right? Now the next question, it is related to the dipole moment. So we are having NF3 and NH3, right? So we will see, first of all, going to the question, we will see how is the structure of this NF3 and NH3 and how their dipole moment is. Now if I take NH3, you will be having a lone pair of electron, and here you have NF3. And here also you will be having lone pair of electron. Let me draw it some other place. Right. So here we are having NF3. So in this case, you have to know how is the dipole moment. You know that the dipole moment will be from a electropositive element to electronegative. In this NH3 case, the dipole moment will be from hydrogen to this particular nitrogen. And you know that this lone pair also will be pulling the electron. And here you can see that hydrogen and the lone pair are having the same direction. The dipole moment is in the same direction. Now coming to this particular molecule, you can see here the lone pair will be pulling the electrons upward. But here among nitrogen and fluorine, here among nitrogen and hydrogen, who is more electronegative? Nitrogen is more electronegative and hydrogen is less electronegative. That's why we are having such a dipole moment. But in this case, nitrogen and fluorine is more electronegative and nitrogen is more electropositive. So we can see that the dipole moment will be in such a manner. So here we can say that the lone pair will be pulling the electrons upward and the dipole moment of the fluorine will be downward, right? So here we are having in opposite direction and here we will be having in the same direction. So with this information, we can read these two statements. So what is this statement 1? Since fluorine is more electronegative than nitrogen, the net dipole moment of NH3 is greater than, NF3 is more greater than NH3. So the first statement is saying that NF3 is having more dipole moment than NH3. It is wrong because here mu will be having the higher value. But here in the case, you know that it is in opposite direction. So mu will be less. So the first statement is wrong because NH3 will be having more dipole moment, not NF3. And in the second statement, what we can see, in NH3, the orbital dipole due to lone pair and the dipole moment of NH bonds are in opposite direction. No, it is not right. Right. In the case of NH, it is not in the opposite direction. It is in the same direction. But in NF3, the orbital dipole due to the lone pair and dipole moments of NF bonds are in same direction. It is also wrong. It is in opposite direction. So here, we can understand that both these statements are wrong. Right, you have seen exactly what is the structure of NF3 and NH3 and how this particular dipole moment is acted. So the first statement as well as the second statement is wrong. So which one is the right answer? Both statement 1 and statement 2 are false. Right, so we have to say that both these statements are wrong. So I hope you understood this question. It's very much related to the concept, and if you know the structure and how the dipole moment is there in NH3 and NF3, we can easily find out the answer for this particular question. Now we will move to the next one. Here, they have asked, select the compound from the following that will show intramolecular hydrogen bonding. Intramolecular. So, what do you mean by intramolecular? Within the molecule. That is intramolecular. It's not intermolecular. It is intramolecular, right? So here we can easily say that H2O, NH3 and C2H5OH. These three will be showing intermolecular hydrogen bonding. And you know the reason for that? Presence of hydrogen, they will be showing intermolecular hydrogen bonding. Now in the case here, the last one, you can see the figure. Here you have N and you will be having OH. So here this particular O and H will be having a bond within this particular molecule. So here this is actually what? It is an intramolecular bond. It's not intermolecular. So what is intermolecular? If the same molecule is present here, and if a bond is formed, it is what? Intermolecular. But this is an intramolecular hydrogen bond because within the molecule, there is actually a bond between hydrogen and oxygen. So we have to say that the fourth answer will be the right one. The fourth molecule will be showing intramolecular hydrogen bonding. Right. Now we will move to the next question. Here, the question is that choose the polar molecule from the following. Right, here we can easily conclude CCl4 will be having no dipole moment. No dipole moment. So it is no polar, it's non-polar. CO2 will be also having no dipole moment, so it is non-polar. Here, ethene is also having no dipole moment, it is non-polar. Now coming to CHCl3, you will be having H and you will be having the electronegative Cl. So here you can see that the chlorine is electronegative and there will be a dipole moment. So in this case we have to say that CHCl3 will be a polar molecule. They will be having this dipole moment and it will be the polar molecule among these four. Right. Now coming to the next question. Sum of bond order of CO and NO plus. So you know that we can find bond order by the formula Na minus Nb, sorry, it is Nb, that is what? Bonding orbitals minus antibonding orbitals divided by 2. You know this particular formula, and using this formula we can find out the bond order. But we can easily find out this using a particular trick. You can just see that 12, 13, 14, 15, 16. Whenever these electrons are there, you just keep it in your mind. When there are 12 electrons, the bond order will be 2. 13, it will be 2.5. 14, it will be 3. 15, it will be 2.5. And 16, it will be 2. So, you just keep it in your mind. This is actually reducing your work. You don't want to draw the molecular orbitals, you don't want to fill the electrons, and again you don't want to look at the bond order, right? You have to look at the number of bonding orbitals and non-bonding orbitals and electrons. All those things are shortened. You just keep this in your mind. If there are 12 electrons, 2 will be the bond order, 13 2.5, 14 3, 15 2.5, and 16 2, right? So in such a sense, we can easily see CO, carbon monoxide, will be having how many number of electrons? You know that carbon will be having 6, oxygen will be having 8. So totally it is what? 6 plus 8, 14 electrons. So 14 electrons will be there for carbon monoxide. Now for NO plus. So for N it will be 7 and oxygen it is 8, but there is O plus. So it will be 7, right? 1 electron is less. So here again you are having 14 electrons. So if there are 14 electrons, we know that the bond order will be 3, right? So this is what? Bond order. So this you just by heart. It will be helping you a lot, right? It is having a pattern 2, 2.5, 3, 2.5, 2. Starting from 12, ending by 16. So here 14 electrons, the bond order will be 3. The both cases. So what is the question? Sum of bond order of CO and NO plus. So what will be that? 3 plus 3. The answer will be 6. So the sum of bond order will be 6. Because CO is having the bond order 3. NO plus is having the bond order 3. And when you take the sum of these both bond orders, you will be having the answer as 6. Right. So I hope this was an easy question for you. You just understand this particular values and it will be very easy for you, right? Now again, this is actually a question related to non-polar molecules. We have to find out which are non-polar molecules among this particular list given. So here you have to see which all will be having dipole moment. That will be polar molecules. Whichever is not having dipole moment will be non-polar molecules. So you just see HF will be having dipole moment and it will be polar. So here HF will be polar. H2O is actually what? Polar. SO2 will be having dipole moment. It will be polar. But H2, right, hydrogen gas will not be having polar moment. So it is non-polar. Now coming to CO2. CO2 will be also having no polar moment. So it is non-polar. CH4 is again non-polar. NH3 will be having, we have seen, there will be dipole moment. So it is polar. Then HCl will be having polar moment. It is polar. Then CHCl3, just before we have seen CHCl3 will be having polar moment. It will be dipole moment. It will be polar. And BF3 will be non-polar. So here what they have asked the number of non-polar molecules from the following. So we have H2, we have CO2, CH4 and BF3 as non-polar. So the answer will be 4. So among this given list, we are having 4 molecules which are non-polar, right? So I hope this is clear for you. We will move to the next question. Right. Now, we have to know the structure of this particular compounds which are given. The number of compounds with one lone pair of electrons on central atom among the following is. So we have to see which all compounds or which all molecules here are having one lone pair in its central atom. So we need to draw the structure of each and every molecule here. So first one we are having O3. So in the case of O3 we will be having such a structure. In this case, you will be having a lone pair of electron, right, in the central atom, on the central atom. And second one, it is H2O, right, you will be having HO. Here you will be having two lone pairs. Now, going to the third one, SF4. You are having a seesaw shape here, and on the center you will be having a lone pair, right? Then you will be having ClF3. So you will be having a T shape, and on the central atom you will be having two lone pair. Then going for BrF5, you will be having 5 fluorine, and the central atom you will be having one lone pair. And going for XeF4, it is actually F4, XeF4, you will be having 4 fluorine, and on the central atom you will be having two lone pairs. So you can see here how many molecules are there, the compounds which are having only one lone pair on the central atom. So we can see that here in the case O3 is having one lone pair, then SF4 is having one lone pair, then we can see that NH3 is having one lone pair, and BrF5 is having one lone pair. So among these 6 we are having 4 compounds which are having one lone pair on the central atom. So the answer is 4, and we have seen the structure also, right? So you just see the structure and just understand how many number of lone pairs are on the central atom. This will be also useful for matrix type of question when they are asking this particular compound and their shape, right? Now we will move to the next question. The number of species from the following which are paramagnetic and with bond order equal to 1 is. So here we have to find out which is paramagnetic and diamagnetic, and also bond order, right? So we have to find out whether it is para or dia. That is the first task. After that we have to find out bond order. So what is the question? We have to find out the species which is paramagnetic and the bond order should be also 1. So we will use this trick that we have already used 12, 13, 14, 15, 16. I have told you 2, 2.5, 2.5 here it will be 3, 2.5, 2, right? And for others we have to see what is the paramagnetic, whether it is paramagnetic or diamagnetic, and also its bond order. So if you take H2, right, H2, we will be having what? Sigma 1s2, right, sigma 1s2. And what will be the bond order? Bond order will be number of bonding electrons minus anti-bonding electrons by 2. So it will be 1. So we can see that bond order is 1, but it is diamagnetic, right? In this first case it is diamagnetic. Bond order is 1, but it is diamagnetic. Now go to He2 plus. He2 plus will be having 3, it is not He2 plus, it is He plus. So He plus will be having 3 electrons. He2 plus will be having 3 electrons. So we can fill it in sigma 1s2, sigma star 1s1. So here what will be this particular bond order? Bond order will be 2 minus 1 by 2, right? Bond order will be 2 minus 1 by 2, it is 0.5. So here it is paramagnetic, this is paramagnetic, but the bond order is 0.5. We need the bond order as 1. So here it is what? Diamagnetic. Now we have O2 plus, right? It is O2 plus. So O2 plus means we will be having 16 electrons minus 1. We will be having 15 electrons, right? We will be having 15 electrons, and for 15 electrons we know that this particular bond order is 2.5, and 2.5 means it will be again paramagnetic, right? Now for N2 minus, so it is what? 14 electrons plus 2, that is 16 electrons. For 16 electrons we know that the bond order will be 2, and you know that it is diamagnetic. So here O2 2 minus will be having 18 electrons and it will be 1. So we can say it is what? It is actually diamagnetic. Now for F2 also it will be what? 18 electrons, right? So here we can say it is what? 1 dia. So what is the question? We need 1 paramagnetic, right? We have seen it is 1 diamagnetic. Now Ne2 plus is actually what? 0.5 paramagnetic, right? Ne2 plus will be having 19 electrons and it will be 0.5 paramagnetic. And last we are having this particular B2, which will be 10 electrons. And when you see that, you will be having bond order as what? 6 minus 4 by 2, right? So it will be 2 by 2, 1, and it will be what? Paramagnetic. So the required answer for this question is that it is B2, right? The last one is actually the combination where we are getting paramagnetism and the bond order as 1. So you have to go for the answer B2. So this particular values, if you know it, it will be easy for you to understand. So all of you just know how these values are coming, and you can see it is following a particular pattern. So just keep that in your mind and you can fastly do this particular problem, right? Now we will move to the next question. The total number of antibonding molecular orbitals formed from 2s and 2p atomic orbitals in a diatomic molecule is. So if you take 2s, we will be having 1 antibonding and 1 bonding orbital. That means we are having 2. Now in the case of 2p, you will be having totally 6 bonding orbitals, and you will be having 3 bonding orbitals and 3 anti-bonding orbitals. That means you will be having totally 6. So in this 2, 1 is anti-bonding and here 3 is anti-bonding. So what is the question? The question is that the total number of anti-bonding molecular orbitals formed from 2s and 2p atomic orbitals in a diatomic molecule is. So you will be having 1 plus 3. Totally there will be 4 anti-bonding orbitals. Okay, you will be having 4 anti-bonding orbitals. Fine. So it's very simple. If you know that concept of molecular orbits, we can easily say that. So here 2s will be forming 2 orbitals, 2p will be forming 6 orbitals, and among this you will be having 1 anti-bonding orbitals in 2s and you will be having 3 anti-bonding orbitals in 2p. And when you add that, you will be getting it as 4 anti-bonding orbitals, right? So in this question, we have to find out the number of sigma and pi bonds. So first of all, we will draw this structure. So it is 2-formyl hex 4 enoic acids. So as it is hex, we will go for 6 carbon atoms, right? And you have to have this acid group. Then we are having this particular formyl group coming in the second carbon atom, right? Now the 4 enoic. So on the 4th carbon atom, you will be having this particular double bond, 1, 2, 3, 4. Right. Now we can go for filling the hydrogen atoms. Sorry. So I guess the all the bonds are written 1, 2, 3, 4. Here we will be having 1, 2, 3. So one more hydrogen should be there. 1, 2, 3, 4. 1, 2, 3, 4. Right. So here, if you count, you can count that. You know that pi bonds will be coming along with a double bond. So here you have one pi bond, right? You will be having one pi bond. Here also you will be having one pi bond. Here also you will be having one pi bond. Whenever double bonds are coming, one bond will be pi. So you will be having 3 pi bonds. And if you count for the sigma bonds, what will be the answer? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18. You will be having 18 sigma bonds. Right. So we have to just check it once again. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18. Right. You are having 18 sigma bonds. So here, and this is also a sigma bond. So it will be 19 sigma bonds, and totally you will be having 22 bonds. So the answer is that the total number of sigma and pi bonds in 2,4-methyl hex 4 enoic acid is 22 bonds. Right. Now, in this particular question, the total number of molecules with zero dipole moment among CH4, BF3, H2O, HF, NH3 and CO2 and SO2. A similar question was done before also, and we have discussed whichever is having dipole moment will be polar, and whichever is not having dipole moment will be non-polar. So here we have to go for zero dipole moment, that means non-polar. So here we have already seen BF3 will be non-polar, and here CO2 will be non-polar, right? Other than this, all will be having this dipole moment, and these two will not be having dipole moment, and they will be having, and CH4 also will not be having dipole moment. So we can say these are non-polar, and we will be having 3 molecules which are having zero dipole moment, right? Now, it's a matrix based question. So we can see already we have drawn the structure of certain compounds. So that particular compounds are repeated again. So BRF5, it will be having a square pyramidal shape. SF4 will be having a seesaw shape. ClF3 will be having T shape, and H2O will be having bend shape. So we can see that A will be going for 4. So there is only one option with A, 4. So the 4th one will be the right answer here. Right. Now we will move to the last question of this particular session. What is the question? The question is that the total number of molecular orbitals formed from 2s and 2p atomic orbitals. So a similar question was done before, and in that question they were asking the number of anti-bonding orbitals. But here they have asked for the total number of molecular orbitals. So in the same logic, we can say that 2s will be having 2, right, bonding and anti-bonding orbitals. 2p will be having totally 6, right. In that, we will be having what? 3 bonding and 3 anti-bonding orbitals. So they have asked the total number of molecular orbitals. So we can say that 2 plus 6, it will be 8. There will be what? 8 atomic orbitals, right, molecular orbitals formed by a diatomic molecule, right. So here comes to the end of this particular video. So we will be having some more questions in this particular chapter which came on 2024 JEE Mains. that will be dealt in the next video. So I hope whatever we have discussed in this particular video is clear for you. If there is any doubt, you can just comment below and we will be seeing in another video. Thank you for watching.